Hello, this is Dr. Churchill for Astronomy 308 into the final frontier. And we're still in module 2 of the class. And this is the space race portion, but we have now passed through the Apollo program, and we've talked about Skylab and the shuttle era. So I'm going to do a little bit more backpedaling into history, go back to about 1965, maybe actually 1950. And we're going to look at the Chinese space program and bring that up to date. So in the context of everything that we've been talking about in terms of the space race, from all the way from Sputnik, all the way through the moon landings, and then through the shuttle program, and the end of the space race, basically with the Apollo-Soyuz handshake in 1975, that the Chinese nation has really been building its space program in a very, very steady way, with several 5-year plans that they've been systematically developing over the time. And this is interesting because they've really embraced a step-by-step process. And this step-by-step process reminds us a lot, when we think about it, of the Mercury-Gemini Apollo phase of the United States program, where they had to learn each of the individual steps from the first, how do you fly in space? How do you get back from space safely? How do you rendezvous? How do you dock? How do you move the joint spacecraft? How do you do an extravehicular activity? How do you navigate to the moon? Basically, as you can see, these steps, and the Chinese have embraced these steps, and they're continually working on them in this systematic way. So we're going to end up spending some time talking about that today. I'd like to remind you, if we go back to the sea race, that we saw that the Chinese were very advanced nautically, that they had an extremely advanced, I wouldn't necessarily call it Navy, but a government-owned fleet of ships that were run by Chang Ho or Zhang He, and that they had 30,000 various members of crew with 300 and something ships, and that they sailed over 1/4 of the world, and did this 30 years before Prince Henry actually got the Portuguese to sail only a fraction of the way down the coast of Africa during the beginnings of the European explorations. But the Chinese turned inward in the 1430s, made it illegal to have ships. We've gone through the story, and the country really turned inwards. And unfortunately, by doing so, then became exploited by the Western powers as they expanded across the globe. And it's taken China a long time to recover from this. And in fact, we could say that they've really only been coming out of this over the last 50 years or so, and really have come to age, I would say, starting in the 1980s, breaking out of this long period of being suppressed and trying to find their way after this shutdown of their exploratory program back in the 1430s. And that's kind of fascinating when you think about that, because that is sort of a warning sign for any country today that might have made great progress in space and now might turn inward and then end up in the future suffering a similar fate of having being exploited by the other powers that do continue to go forth. Okay, so that's part of the story here. So as we're talking about the Chinese space program, I'd like to always keep that in the back of your mind. So let's do some screen sharing today. And here we go. I'm going to enlarge myself just a hair here. Okay. All right, so here's my opening slide on the Chinese space program. In modern days, they call themselves the Chinese National Space Agency. And you can see the logo here in the middle for the CNSA. And I'm going to describe that just a little bit here, but I'm going to show the photographs You can see this is a picture of an astronaut, but they're really called taikonauts, doing a spacewalk. And so if you weren't aware that the Chinese have flown in space, well, welcome to the new world. They've had taikonauts in space since 2003. This is their vehicle assembly building. As you can see, it's, I think, in a sense, modeled after the NASA vehicle assembly building. And it appears that they will actually build their rockets by stacking them straight up in a vertical way, rather than the Russians and the Soviets we saw built them horizontally and then tilt the rockets upward. Okay, so let's look at this emblem because it's very symbolic. In the middle, we have this upward arrow, remind you of Star Trek, I think, a little bit. And this is a Chinese character that stands for human or people. And you'll notice that it's standing above or sticking out of these rings. And these are 3 concentric ellipses, the ellipse having significance in that the shape of an orbit is always an ellipse. It's never a perfect circle. Now, the first inner ring corresponds to the achievement of escape velocity from the Earth. So in other words, being able to escape the Earth system itself. Excuse me, that's the second ring. The first ring is to a sustained orbit. In other words, to be able to take a rocket or a satellite and put it up into orbit. And so that's the first ring. The second ring is representative of escape velocity from the Earth. So in other words, being able to send something to the moon or to Mars or out into the solar system. And then the third ring indicates being able to escape from the solar system itself. And as of now, the United States is the only country that's achieved that with their Voyager 1 and Voyager 2 spacecraft, which are actually heading out into interstellar space right now. The second ring is thick because this is where the CNSA has their level of achievement at this stage, okay? Which is to mean they have sent things outside of the Earth's gravity, and in fact, they've sent things to the moon, and they've sent spacecraft to deep space, and one that actually rendezvoused with an asteroid. So there's some stories to tell here. Again, the character which would indicate human is sticking up above the rings, indicating this capability to explore for humans. It's very symbolic. And then the olive branches were finally added as a way of indicating that this is a peaceful program. Now, in the sense that the United States had Wernher von Braun and the Soviets had Sergei Korolev, we see that the Chinese have their rocket king, if you will. He's actually known as the father of Chinese rocketry and has been nicknamed the king of rocketry. And this is Tianong Program. And he actually passed away in 2009, but he was an extremely intelligent young man. He came over to the United States and studied at MIT. He then moved over to Caltech as faculty and helped co-found the Jet Propulsion Laboratory, which then became an arm of NASA as well. He did finally return to China, and he changed his name to Quan Shisen, and I'm sorry, to Xian Shisen. And then he basically built the entire missile and space program for the Chinese. It turned out that during the 1950s, he was singled out and accused of having communist sympathies. And this was a big deal in the 1950s. It's a whole history that we won't get into at this stage. But of course, he had very high security clearance because he was such an important figure in the programs. And he was stripped of his security clearance, and then he was put under house arrest, and he stayed in house arrest for 5 years. Finally was released in an exchange for some American pilots that were captured during the Korean conflict, which is another rich piece of history between the United States and China and the Cold War, serious Cold War hotspot, if you will. So anyway, he helped the Chinese make their first atomic bomb, and he helped them become the 5th nuclear nation capable of nuclear bombs. And then he also was involved in the development of their missiles and then the founding of their Chinese space program. So we're going to talk a little bit about some of those accomplishments. Speaking of accomplishments, this is a mosaic of many of the recent accomplishments of the CNSA. And I would like you to understand that none of these are simulations or artist renditions. These are all actual photographs of activities that are happening, and you can see they have a very vibrant space program. So giving you a little bit of a history, we're going to do a 30,000-foot flyby over the decades, going again back to the 1950s, which brings us back to the time of Sputnik. Okay, so in 1956 is when they developed their first plan for some kind of Chinese aerospace initiatives. Now you have to understand that in 1949 was the end of the Civil War in China between the nationalists and the communists won, and China officially became a communist nation in 1949. So this was in 1956, a year before Sputnik, a year before it's called the geophysical year, which was supposed to be a global collaboration of technology celebration and scientific projects amongst the world. In 1956, in preparation for this, they put together their 12-year plan for aerospace. In 56, that's also shortly after they put together this program, is when Xian Shexin was deported to China. And then in 58, they started something called Project 581 in May of 1958. And this was actually a goal to put up the first satellite in space, which you can imagine the Soviets had put theirs up in October of 57, the United States in January of 1958. And so by May, the Chinese decided that they wanted to be also a spacefaring nation. And let's not forget, space is seen as the high ground, the new ocean. We've talked about if you owned the most powerful navy in the world, you controlled the world. That was England. They had the largest empire that covered the entire globe. Nobody was able to really compete with them. And people hadn't forgotten that lesson. And so the idea would be, let's build our navies in space. And so the first step was just to, be able to get into space and put some kind of permanent object around the Earth. By 1960, they'd actually done their first successful launches. So they were really getting into this. And of course, they had the Soviets, the other communist nation, really helping them out. And they'd used one of Korolyov's R2 rockets to do this. In 64, they took their first official step into space and launched a biological experiment on a rocket. They had some white mice. And of course, this is definitely following the model of the Soviets, who had sent up dogs in Sputnik 2. They sent up Laika. In 67 now, so this is during the period just following the fire, which happened in January of 67. And I can call that event the fire, meaning the Apollo 1 accident with Gus Grissom, Ed White, and Roger Chaffee. So then they really started their astronaut program in earnest at this point in time, and their goal was to put 2 people in space by 1973. And they actually, I've seen documentaries on this, they have very, very active astronaut selection program going on, and they had selected about a dozen of these young men, test pilots, of course, and it all fell apart eventually. Unfortunately, it got canceled in May of 1972. And during the 70s was something called the Cultural Revolution, which was instigated by their, I'd like to call him a dictator. His name is Mao Zedong, and he was really the leader of the revolution, the communist revolution. And he took over as the communist leader, very much the way Lenin had in the Soviets and then Stalin. So he started something called the Cultural Revolution in the 1970s, and this really was just frankly a terrible time for the Chinese, with lots of persecutions and people being moved out of cities into the rural areas to work in the fields and put on communes, and intellectuals being persecuted and imprisoned into work labor camps and things like this. So 1970, we'll go into this middle panel here. In April, they had the launching of their first satellite. So they did succeed at that. This was called the Dongfeng Hong 1. This satellite actually is still in orbit around the Earth. Okay. Fast forward to 1975, they had their first recoverable satellite. So that was the first time they launched anything, and then it had it re-enter back into the atmosphere. And that is a big step, as you know, to learn how to have something re-enter into the atmosphere, because of course it's going through that huge fireball as it heats up on the atmosphere on its return from orbit. Okay, now we'll fast forward to the 1980s, and they've started to start something called Project 863. My kitty cat's hungry. Okay. And this was a way of getting some crewed missions started, and they planned to actually develop a space station and work toward this. And they did make progress on this, but then they revamped it in 1992 and turned Project 863 into something called Project 921. And Project 921 is the project by which they had obtained all of their greatest successes. So here we are in January of 1992, and Project 863 has turned into Project 921. And by 1999, they had successfully launched their first uncrewed spacecraft called the Shinsao-1. Now, this is an important step as well. You know, SpaceX has recently flown astronauts up to the International Space Station now, but these crewed missions, of course, came after uncrewed missions. So they had to prove everything about the spacecraft to demonstrate that it was crew worthy before they actually sent it up. So they have accomplished this just about the turn of the century in 1999. Okay, this is the second slide out of 2 on the 30,000 foot view. In the early 2000s, okay, they really made their first stride to putting humans in space. And it was in October of 2003 that they became the first nation under the power of their own rockets, with using their own space agency and trained people, and their own astronaut launching from their own territory and put a human in space. And this gentleman, Yang Liwei, flew for 21 hours, and this was Shinsao-5. So you can see they had several test missions, 2, 3, and 4 before he flew. Now, if we move to February 6, 2004, then China has said, you know what, we're going to go to the moon. So around 2004, they say, we're going to go to the moon. We're going to get a landing on the moon by 2010, and we're going to do a sample return by 2020. And, you know, spoiler alert, they accomplished that. They just returned the sample back in December of 2020. They nailed it, okay? October 2005, they sent 2 men on a 5-day flight in the Shinsao-6 spacecraft. So now we have the equivalent of the first Project Gemini mission, Gemini 3, where 2 astronauts have gone up together and come back down. Okay. In 2006 now, they're going to set 2024 as their first moonwalk. All right, that's 3 years from now. And what I'm going to hopefully show you by the time that this lecture is over is that, in fact, they know how to do every single step of this, apart from the actual putting the person in the cabin and taking them out to the moon. But they've mastered every step of taking a person to the moon. China's first lunar orbiter, Chang A3, entered the moon's orbit in 2007. Okay, and then in 2008, they had a third crewed rocket that went to orbit, and then they had their first spacewalk. So the equivalent of Gemini 4 or the equivalent of Voskhod 2, those happened in 1964. So you can see that China is very much behind the United States and the Soviet Union at this point in time. But what we're going to see here is a complete and total catch up. Okay. By 2010, their Chang A3 lunar and deep space probe orbited the moon, and then it went for deep space and rendezvoused with an asteroid. So this is when they really achieved that second ring. I would say in 2008, in 2007, when the Chang A1 went, is when they achieved that second solid ring, but they really achieved escape from the Earth-Moon system in 2010 as well. Now we're going to end up having some orbiting space labs. In 2011, the Tiangong is their first orbiting space lab, and it was launched, and it's designed for docking experiments and rendezvousing. So you can see now we're moving to the equivalent of the middle of the Gemini program, say like Gemini 6 and Gemini 7, and then Gemini 8, where you have the docking. In 2011, they actually carry out their first docking. So now they're up to Gemini 8 mission in a sense. I hope you don't mind my always comparing. And this was the Shenzhou 8 and the Tiangong 1. In June of 2012, they sent up the first woman, okay? And this was also another mission where they did a docking and with the space station. So they've now duplicated their ability to rendezvous and dock. And then finally, they had their third moon mission in 2013, the Chang A3. It actually landed on the moon. So now they've done a soft landing on the moon. This is it's been since 1976 since the last soft landing was successfully achieved on the moon. And now they've joined the United States and the Soviet Union as being the third nation to accomplish that feat. Let's talk about the last few years, 2016 to 2019. Okay, so they launched a Tiangong 2 space laboratory. So now they have 2 space labs orbiting in space. And this is part of a broader plan now that they want to have a permanent manned space station around 2022. In January of 2019, the Chang A4 lunar probe launched in December. And this was again, we're only talking 2 years ago. And so this actually landed on the far side of the moon, and they are the only country to successfully soft land anything on the far side of the moon. And as I'll describe later, this requires some additional aerospace engineering and planning that, again, they're the only ones to achieve. Now let's jump to 2020. They started to put up some satellites doing the GPS, and so they're basically building their own network here, which allows them to be independent as far as GPS and global positioning kind of thing goes, telecommunications. And then in 2020, in July, they sent an unmanned probe to Mars. I'm not going to be spending a lot of time talking about that during this lecture, which is a shame, but I don't have a slide on this mission, but they actually have a probe that is orbiting Mars, and it's going to send down a rover as well. So they're going to soon be the only other nation to do that besides the United States. In November of 2020, they launched their uncrewed mission called Chang A5, and this was designed to collect the lunar samples and bring them back to the Earth. And so it landed, it grabbed its sample, it took off, it came back and landed on the Earth, and they collected the samples. I'm going to talk about this mission a little bit. And this is the mission which in my mind demonstrates that China is ready to send a human to the moon. And it's because they've mastered every single step from launching to orbiting, rendezvous, and docking to navigating to the moon, okay, landing on the moon, lifting off from the moon, and then doing orbital lunar orbit rendezvous. Because it turns out with Chang A5, there was a mothership that orbited, and then the samples that were collected from the surface of the moon were brought up. There was an automatic lunar orbit rendezvous, the only nation to ever accomplish that. And then they transferred the materials to the mothership, and then the mothership did a trans-Earth injection and came back re-entered the atmosphere, and basically now they've accomplished every single step that's required to send humans to the moon. As far as facilities go, you can see that the Chinese have really spread them out about their country. And, we have NASA Ames Research Center and Langley and Johnson and Cape Kennedy. We have several NASA centers as well, but we really only have one major launch facility, for example, which is Cape Canaveral / Cape Kennedy. And you can see here that they've really built some infrastructure across their whole country. So in green, we have the launch facilities, and there's 4 of these. I can point them out here, 1, 2, 3, and 4. And then we have 2 control centers, so 2 sort of Houstons, if you will, one here in the center of the country, one up here by Beijing. We have the landing site, which is up here in the northern part of China. And then we have what are called space cities, which is a name that's taken from the way that the Soviets and Russians would call their areas where they have all their infrastructure for building the rockets, testing the rockets, and like I say here, engineering, manufacturing, research, and training of the crews. So in 1970, this is their first foray into Earth orbit in 1970 with the Dongfeng Hong 1. Okay. It was launched, of course, about 13 years after Sputnik 1, and it was proposed by Chiang A3, and then it was actually personally approved by Mao Zedong himself. And here are the 2 characters here. Here's Mao, and so he was the all-powerful leader of China for many, many years. And then here is the father of rocketry, or the Rocket King himself. We have a nice stamp here commemorating this. Here's a picture of the spacecraft being built in its white room. Here's a photograph of what that looks like. It's 72-faced polygon. It's about a meter in diameter, weighed about 380 pounds. It's pretty heavy compared to, say, what the first Sputnik was, which was 180 pounds. Anyhow, it's still in orbit, so that's kind of interesting. And its batteries lasted about 20 days, where it did some transmitting and space readings. I don't really know what that means. It sounds like a euphemism for it didn't really do much science, but I really don't know the details there. Anyway, it's been quiet since May 14th of 1970. So here's Project 921's crewed missions. They have been they lasted from 2003 to 2016. And so what China has been doing in the interim between 2016 and now is mostly working on their Lunar Program. But as I'll talk about in the next slide, they do have some plans, particularly for building their permanent space station. Now, one of the things we'll learn later, not in this lecture, but in a future lecture, is that the Chinese were banned from the International Space Station by a policy instigated by the United States. And so they basically decided to go off and do this on their own. So they've flown 11 of their taikonauts, and I think this is basically the same thing as astronaut and sort of like, universe traveler or cosmic traveler. It's very similar in the same way that we call Americans astronauts and the Russians cosmonauts. Of these 11, 2 are women, which is really awesome. So the first flight was Shenzhou 5, October 2003, and that was with Yang Liwei, and this is a picture of the gentleman here. So that must have been a fantastic experience for the country and for him. Shenzhou 6 had 2 astronauts, so this is like our first Project Gemini. This is in October of 2005. And then Shenzhou 7, we have 3 astronauts, so they went from 1 to 2 to 3 person crews. 1, 2, 3, and this was in 2008. So you can see they're on a pace about every 2, 3 years. And then another 4 years goes by, and we have Shenzhou 9, and this is the first Chinese woman in space, and then the first rendezvous and docking with the space station. So again, step by step by step process that's going on here. Then Shenzhou 10, we have a 4-person crew. We have the second Chinese woman in space, and also the docking with the Tiangong 1 Space Lab. Okay. And then finally in 2016, we have the Shenzhou 11. This rendezvoused and docked with the Tiangong 2 space station. And in here, we did do a spacewalk, which doesn't seem to be, oh, here it is, I'm sorry. This is the first spacewalk here at Shenzhou 7. I forgot that I told you that already. Anyway, here are our taikonauts, our Chinese space heroes. And here's our first woman, Liu Yang. And I would also like to point out Jing Haipeng, I think is how you pronounce his name. And he actually has made 3 flights. So he seems to be one of the favored astronauts, certainly must be one of the most mature and ones that they can count on. Now, the Tiangong program is an extension of Project 921, and these are the planned crewed missions from 2021 forward, that there would be a total of 15 taikonauts that will crew these missions. We have Shenzhou 12, 13 through 16. The durations are all to be announced. The plans are for Shenzhou 12 to fly in June 2021, so watch your news reels for the summer. We'll see if China flies. And then in the beginning of the fall, in September 2021, and then March of 22, and then we don't know exactly what's going to happen with 15 and 16, somewhere between 22 and 23, but each mission should have 3 taikonauts. And these missions are basically to start building and constructing the new Chinese space station. So this is really a big step for a permanent presence in Earth orbit. And as you can see, they're working very hard on a presence on the moon, which I'll talk about their long-range goals for a base on the moon as well. So here's a couple stops on the way. This is Shenzhou 9 with the Tiangong 1. This was the first woman, Chinese woman who launched, and this was their first rendezvous and docking. So this was a spectacular mission for the Chinese space program. It really demonstrated a great leap forward, if you will, in their program. Here we are. The astronauts gave a little bit of an educational lesson to some students from space, little sort of classroom in space exercise. Shenzhou 11 docked and rendezvoused and docked with Tiangong 2. And, you know, the point is it's step by step by step by step, and they're doing a great job of advancing their program one step at a time in a very systematic way. So this is the plans for the Tiangong 3 space station. The word has it that this has actually been canceled in its present form, but it's still on the books for the missions to fly that would be involved in the construction of the space station. So I don't know exactly what the plans are, but this particular design of the space station has apparently been canceled. But you can see here that it rivals the International Space Station in terms of its size. So if you'll recall, we talked about the Mir space station, which was the Russian space station that flew from '86 to 2001. And then this would be the Chinese space station, Tiangong 3. And then this is what the International Space Station looks. And I'll later be talking about the ISSS and how it was built. And I have some really good how does it work videos that I found on YouTube that are quite excellent that I'll be pointing you to. Okay, let's talk about their lunar program, because I think this is where it really gets fascinating. Chinese Lunar Exploration Program, or CLEP for short, is divided into 4 phases, okay? And the first is an orbital mission, the second is actually soft landing, the third is sample return, and the fourth is to build a lunar research station. Now, if you happen to be paying attention when I did the 30,000-foot view of their program, you'll note that in fact they've already accomplished goals 1, 2, and 3. okay? And now they're working on number 4. So they've done Chang A1 and Chang A2, and they've done basically orbiting and high definition mapping with Chang A1. They did a parking orbit test with the Chang A2. Now, what do I mean by that? I'll explain that in a bit. This is L2 parking orbital test. L2 is a acronym for Lagrangian point number 2, and this is a gravitationally stable point that is on the far side of the moon relative to the Earth, and actually follows the moon around the Earth, is always behind it from our perspective. And it turns out that you can park things in this little gravitational well that's stable and orbit around it. Even though you're not orbiting around an object, you can orbit around this stable point. And so they tested that, and then they did some flybys of the asteroid 4179 to Tautis, and they got some great pictures of that. Okay, number 2 is the soft landers. Chang A3 has the U2 rover, which is, I think, Jade Rabbit is the name of it. And Chang A is a mythical character that I can't remember the story, but is involved with traveling to the moon or being trapped on the moon, your classic mythology. And she had a rabbit pet, and Jade Rabbit. And so the rover was named after the rabbit. This was, again, the rover went on the moon. This was on the near side, and then it lasted about a month. Chang A4 landed on the far side of the moon. Again, it's the first one to ever do so. And this happened just 2 years ago in December 2018, and then had the U2 rover. And that mission is still operational. Then 3 was the Chang A5, and the Chang A5T is the small capsule that brought the lunar samples back to Earth. And so this is the one where they mastered every step that's required to do a human landing on the moon. And it turns out that they returned about just under 4 pounds of moon soil. And that was collected on the 16th of December of 2020 last year. And then planned is Chang A6, 7, and 8. And this is to actually do reconnaissance to find water. In other words, do more sample returns, try to find where the water is in the South Polar regions. If you haven't heard in the news, there is some South Polar regions where there's permanent permafrost of water that's in the soil of the moon. And this is supposed to be, there's supposed to be quite a lot of it. And in fact, this could be something where people could just mine the soil, extract the water, and of course you can do all kinds of things once you have the water, from building rocket fuel to using fuel cells and getting oxygen as well. Okay, so right, we'll be talking about these things coming up in the next few slides. So here's an overarching view of the Chang A or China's lunar probing missions. Starting with Chang A1 here, it happened in 2007, Chang A2, which happened in 2010, 3 with the rover, the landing on 2013, the dark side of the moon, little Pink Floyd for you, the far side of the moon with Chang A4 and U2, and then the Chang A5 sample return. This is the launch, and then this is the sample return. In the future, we have along this arc of trajectory is the Chang A6, 7, and 8 that I was talking about for eventually building this lunar research base. So here's Chang A1, here's the launch. Here's an image from its high resolution camera. There's some of the most high resolution images of the moon that we have now. They obviously want that so that they know where to land, can navigate around the moon with accuracy greater than any other nation. Here's an example of it doing this radar work to collect the data. Okay, this launched in October of 2007, made the most high definition 3D map, and it's basically proved that they could go into orbit around the moon. So that was a fantastic first step. Chang A2 This had the asteroid flyby that I was talking about. Now, it launched in October of 2010. It got to the moon in 5 days, so it went much more quickly to the moon than Chang A1, which took 12 days. But as you can see, it had a very set of complex orbits. We did a lot of Hohmann transfers here. So we went from a large elliptical orbit down into a small parking orbit. And then it did this little test where it orbited around this L2 point here, which is that stable gravitational point I was talking about. And then it left that orbit and it went into deep space and it met up with the Taikonauts asteroid. And then here are some of the photographs as it approached, getting closer and closer. You can see the mosaic of images there. Chang A3, their first soft landing on the moon. This is where it landed, if you're interested as far as the geography goes of the landing. And oops, that shouldn't be there. So this launched in December of 2013. And then once it landed, it let U2 go out. And this is a time-lapse photograph of photograph 1, photograph 2, showing the motion of the rover. Here's some up close and personal high definition pictures from that mission. It turned out that there were some issues, mechanical issues that happened with U2. So it really didn't last beyond a month, which is most of a lunar day. So it turned out that it was, in the end, supposed to do a lot of science, ultraviolet observations, looking for UV light coming from galaxies and the black holes in the centers of galaxies, called active galactic nuclei, to study variable stars, novae, quasars, and blazars. These are all high energy objects that it was supposed to be studying, doing some science. Now, Chang A4, this is really a spectacular mission. First, what you'll notice is that we have a satellite shown in red here, which then comes out and orbits around this L2 gravitational stability, the Lagrangian point number 2. And this always is on the opposite side of the moon from the Earth. So as the moon goes around, this L2 point follows it and is always on the far side of the moon relative to us. Now, this is really important because if we have a spacecraft that's orbiting around here and it always has line of sight visibility to the Earth, that means that it can always be in radio contact. Now, if you are going to land a craft on the far side of the moon, it is not going to be in radio contact. So then now you can use the satellite orbiting in the L2 spot as a relay station and have permanent radio contact with anything that's on the far side of the moon. The only nation to achieve this is China. Here are some photographs from the Lunar Reconnaissance Orbiter, which is the LRO. This is the United States satellite. And you can see the Chang A4 and you can see U2 too. Again, this is the far side of the moon. Here's a picture of U2-2. Here's a picture from U2-2 of the Chang A4. And then, of course, a nice up and close personal view of the moon. This is another diagram showing you basically geographically where it landed and sort of the geometry of the L2 location compared to the Earth. So here's the Earth with the moon orbiting, and this point out here is always on the far side, as I've said before, of the moon. And as these orbit around this way, they go in lockstep. And so the Quo, I don't know how you pronounce that, relay satellite for Chang A4 would orbit around and always had a direct line of sight for radio contact with the Chinese star cities and control centers. On the far side of the moon, which is much more rough than the near side, you can see down here in the southern area called the von Karman crater of the South Pole Aitken Basin. This is the area where it's believed there's permanent water frost, actually a little further south of that, indeed. But this was a test area that landed down here in an area that they thought that would be a good example of the type of materials that they might want to look for when they build their station, permanent station. Okay, again, here's some more pictures of U-22. Here it is up close, and then here's a picture of the Chang A5 or Chang A4 from U-2. Chang A5. Again, this is the most recent mission. It just returned in December of 16th of 2020. It launched in November of 2020. You can see from the launch, it goes out to the moon, goes into a parking orbit. We have the in a sense, I'm just going to call it the mothership of Chang A5. And then we have the lander that comes down. The lander picks up some soil. So this is an artist's rendition showing you the robotic arm and the capsule that gets the core sample. It gets then put back into this upper stage. The upper stage then, very similar to the ascent stage of the lunar module, then lifts off of the bottom platform, and it then went up and it rendezvoused and it docked with the mothership. And then we did the TEI, Trans Earth Injection Burn, and we came home and we re-entered the atmosphere, and we have mastered every single step required to send a human to the moon. Okay, here is where the Chang A5 was picked up and the soil was extracted. Here's a nice picture of one of the legs on the moon, so you can see the artist's rendition compared to reality. And then, you know, just an example of the fact that they have trained up a cast of thousands of people now who are trained to do these space missions in the same way that the United States was trained to do them back in the 60s when we went to the moon. We now don't have that type of personnel or that body of personnel to do that kind of thing. And once we shut the space shuttle down, we really shut down the entire culture of spaceflight in this nation since 2011. So for basically 10 years now, we have not had at least a NASA run or government run team that is practiced and efficient and proficient in spaceflight. That really belongs now to SpaceX mostly. Okay, budget. Who needs a stinking budget? Well, let's just do a quick comparison here. And in fact, this reminds me that I want to say that the spacecraft payload is filled with a small budget. Okay, so that's going to be my attendance word. Now, let's look at the top. This is the amount of money in millions of dollars. So this is $2,000 million, which I believe is $2 billion. And you can see here that this is the amount of money that China has been spending since 2011 all the way up to and projected between 2026 and 2030 is sort of in the $2,000 million range. Whereas you've got NASA here through the same period is up here at 2 to 3 times as much money annually in the sort of 6,000 million range. So this is kind of interesting that China is accomplishing all of this with about 1/3 of the cost of what the USA is doing. And I think this really is a wake-up call that the United States should really think about how to become more efficient at doing spaceflight and developing some long-range plans and sticking to them. One of the weaknesses of our nation, which is also one of its strengths, but one of the weaknesses is the fact that every 4 years we can have a new president or a new administration, or at least on the order of every 8 years. And really, and then we have these staggered elections with Congress, the lawmakers. So there's all this flip-flopping going on with the United States, and we really don't have these developed plans that we stick to, so to speak. This is space news as of October 2020, just to let you know that they are really pushing forward. And when I talk about long-term plans, they're currently drafting their 14th 5-year plan for the period of 21 to 25, okay? And they have some white papers out right now, so that what they do is people propose these things in white papers. They select from the white papers the things that they want to do. Then they work as a committee and codify that into a 5-year plan. Okay. Meanwhile, they're proceeding with robotic lunar exploration efforts. They're targeting the moon's south pole. Chang A3, 7, and 8 will be part of their proposed International Lunar Research Station that's being developed over the next decades. And so here is an artist rendition of the ILRS, International Lunar Research Station. I really do not know what the word international means in this regard, but in a sense, we have to wonder about space law coming in the future, because in a sense, one could argue that this is a land grab. You could argue that if the United States was to, say, claim the Apollo lunar landing sites, that would be a land grab. And right now there's a space treaty out there, something we'll get into in the third part of this class, module 3, is the space law and how that has hampered space growth and how it's going to be pushed against very, very hard. That these laws are going to need to be developed. There's going to need to be an international body, which is going to be a huge transformation in the world. In the meantime, these private companies and nations are going to be pushing forward faster than the laws could keep up. And so a lot of precedent will be set just by what people do. And the question is, will they behave, or will they just look out for themselves and move forward? And you can imagine, given the arc of the sea race into the present day, that one could imagine that it's going to be out of the control of those who would like to regulate it and control it. Okay, so that's my Chinese space program. And there are some supplementary videos that I would really like you to make sure that you watch, and that will fill in some of the gaps as to the things that I didn't talk about. And I would encourage you to go Google their Mars rover and their Mars orbiter. So when we come back next time, we're going to talk about an overall view of the various nations and what they've been doing in space, Israel and India, Japan, and we're going to be able to compare and contrast those and maybe look at a couple private companies, but really we're saving that for module 3. So I hope you enjoyed today's lecture, and we will see you around next time. Thank you.